Today we're going to be talking about exponents. Go ahead and open your notebook to the next available page, and you can put today's date at the top of your page as well. Oops. Okay, and the title of our notes today, we're going to be in Topic 3, Lesson 1, and it's Understand and Represent Exponents. So we're going to look at an example of an exponent problem to start with. And we're going to use this to kind of identify different parts of an exponent problem. So if you take a look at this, the number that's written bigger right here, this is called the base. So 5 is our base. And then the smaller number that's written up here, in this case it's the 3, that is called our exponent. And so basically with these exponent problems, the exponent tells you how many times you're going to multiply the base times itself over and over again. So in this case, since we have 5 to the third power, we're going to multiply 5 times itself 3 times. So that would be 5 times 5 times 5. So if you multiply this out, 5 times 5 is 25. And then 25 times 5 is 125. And so you'll notice there's a big difference here between exponents and just multiplication. If I were to do 5 times 3, that's really just repeated addition, 5 plus 5 plus 5, which would equal 15. Whereas with exponents, we have repeated multiplication. So let's go ahead and define the base and the exponent. So with these exponent problems, the base is basically the number that is repeatedly multiplied. Like here, the 5 is repeatedly multiplied. So it's the number that is repeatedly multiplied. And then we have the exponent. And the exponent is a number that shows how many times a base is used as a factor. So here the 3 told us that we're going to use 5 as a factor 3 times. So it's a number that shows how many times a base is used as a factor. So what we're going to do is look at a couple different examples. We're going to create a table to look at these examples. And so right below here, I'm going to create a table with 3 columns. We're going to have exponential form, expanded form, and standard form. So on the left here, I'm going to go ahead and label this exponential form. And this column doesn't have to be very big. The middle column is going to be expanded form, and that's probably the column that's going to take up the most amount of space. And then lastly, we're going to have standard form. So let's take a look at the first example. So the first example is going to be 3 to the 6th power, or we could read that as 3 to the power of 6. So exponential form is basically when we write the problem using a base and an exponent. Now we're going to move into expanded form. In expanded form, we're basically expanding the problem, and we're going to write out the multiplication problem that we're going to work out. So in this case, the 6 tells us that we're going to repeatedly multiply the 3 over and over again 6 times. So that would be 3 times 3 times 3 times 3 times 3 times 3. So I have 1, 2, 3, 4, 5, 6 threes. So that's called expanded form. Standard form is now basically the answer. We're writing it the way we normally see a number. It is okay at this point to use your calculator to figure this out if you'd like to. You just want to make sure you're typing it in the right number of times and you're typing it in correctly. Some calculators like mine will show you the problem as you type it, which is kind of nice. Others will not show you that. So you have to really keep track of how many times you type the number in. So what I like to do is I like to count as I type it in. I know I need 6 threes. So I'm going to count 1, 2, 3, 4, 5, 6. And after that sixth 3, I'm going to hit equal. And I see it's 729. So our standard form is 729. All right, let's look at another example. For the second one, we're going to have 12 to the third power, or 12 to the power of 3. We can also read this as 12 cubed. So the exponent of 3 is kind of has a special way to read it, and that would be cubed. So in expanded form, the 3 tells me that I'm going to repeatedly multiply the 12 3 times. And then go ahead and try and figure that out on your calculator. You can pause the video, and once you think you've got it, go ahead and unpause. So I'm going to type this into my calculator, 12 times 12 times 12, and you can see we get 1,728. You can see the values really get bigger fairly quickly, and that's because we're dealing with exponents. If you've heard someone say, wow, that grew exponentially fast, that's what we're talking about. The value increases really, really quickly. Now, let's look at example 3. We don't just have to do this with whole numbers, we can also use decimals. So for this one, we're going to do 1.4, or 1 4/10, to the fourth power. So, as a multiplication problem, the exponent tells us we have to multiply 1 4/10 times itself 4 times. And there's different ways to write this. I prefer not to use the dot for multiplication when I'm dealing with decimals if I don't have to, just because it looks kind of like a decimal point. So again, go ahead, you can pause the video, plug that into your calculator and see what you get, and then when you're ready, you can unpause it. Okay, so I'm going to go ahead on my calculator, type in 1 4/10 times 1 4/10 times 1 4/10 times 1 4/10. And that gives me an answer of 3 8,416 10,000ths. Okay, let's do one more example like that. We're going to look at number 4. And just like we can use exponents with decimals, we can also use them with fractions. So I'm going to go ahead and write down 1/2, and I want to do 1/2 to the 5th power. Well, when you're dealing with fractions, if you want both the numerator and denominator to be raised to the 5th power, we need to put parentheses around it to show that the exponent is not just applied to the numerator, it's also applied to the denominator. So that would tell me here that I'm going to multiply out 1/2 times itself 5 times. So 1, 2, 3, 4, and 5. Now, there's different ways you can do this. One easy way is to just multiply your fractions. So I'm going to multiply my numerators straight across. So 1 times 1 times 1 times 1 times 1, well, that's just 1. And then I'll multiply my denominators. So 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. And 16 times 2 is 32. So 1/2 to the 5th power would give me 1/32. All right, so now we're going to look at a special exponent. We're going to create another table below, and we're just going to leave a little bit of space between the two tables. And what we're going to look at is numbers that have an exponent of 0. And we're going to kind of learn how to do this by looking at other exponents that have a base of 10. So we're actually going to skip this one to start. And we're going to start with 10 to the first power. So to write 10 to the first power, well, in expanded form, the 1 tells me I need to write down the 10 one time, so it's just 10, which would also be our standard form, 10. Now let's look at 10 to the second power. So 10 to the second power would be 10 times 10. 10 times 10 is 100. Hey, let's do a couple more. If we have 10 to the third power, that would be 10 times 10 times 10. 10 times 10 is 100, and 100 times 10 is 1,000. And hopefully you're starting to see some patterns here. Let's do just one more, 10 to the fourth power. So that would be 10 times 10 times 10 times 10. And if I multiply 10 times 10, that's 100. Times 10 is 1,000. Times 10 is 10,000. So take a minute here to look for some patterns. So you can pause the video and look to see if you can find a pattern that would help us figure out what 10 to the 0 power would equal. When you're ready, you can unpause the video. So if we take a look at our patterns here, every time we increased our exponent, we also added a 0. And not only did we do that, but also if you look at like here, the exponent is 1, our answer is 1, 0. Here the exponent is 2, our answer is 2 zeros. And we could do that all the way down to here. Like here, 10 to the fourth power, there's an exponent of 4, and we have 4 zeros. So if we go to 10 to the 0 power, that means we should have a 1 with no zeros. And so 10 to the 0 power is equal to 1, which would also be our expanded form. And this is actually true for any base to the exponent of 0. So that's a really important fact that we want to make sure we copy down. And that is that any number to the 0 power equals 1. Okay. So you should have a better understanding of exponents now. The last thing I wanted to go over is there are 2 exponents that have a special way to read them. We already talked about one of those, which was this one here, and we said that would be the same as cubed. So I could read this as 10 cubed, or 10 to the third power, or 10 to the power of 3. And then here, 10 to the second power, I could also read as 10 squared. So those are the 2 that have just a special way to read them. Okay, so now you should be comfortable using exponents. You can use your calculator to actually figure out the standard form, but you should know how to write it out in expanded form as well.